the predictors or the explanatory variables. Okay, and these variables, we call them risk factors. Risk factors, why? Because usually in actuary, as an actuary, we do a pricing model using JLM. And in motor, you have risk factors. This risk describes the behavior of, let's say, if we are doing a motor pricing. Okay, so you have also information about the driver, the age of the driver, the gender of the driver, the occupation of the driver. Okay, and also the information about the vehicle that the driver is using. For example, the vehicle age of the driver, the body type of the vehicle. Okay, and also you have information about the policy. From where he bought the policy, the region or the city, if it's from an agency or, I mean, brokers, or from a direct sales agent, okay? So this we call them risk factors. These are the explanatory variables, the predictors, this X, okay? So you have this X, this is the first component, and then you have the mu, it calls, here we call the target variable, yes, we call it target variable. It's a variable that you want to predict. Okay, so then the third component is a link function, it's the J. Specifies the link between the random and the systematic components. And we'll have it, the JLM model, as a function, an equation. Okay, for example, here we chose that the link function is a logarithmic. So we have the logarithmic of mu equal beta 0 plus beta 1 x1 plus blah 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 xp xp. Okay, it's like that. You can calculate your target variable based on the systemic components, the x's, and the calculated coefficients, and the link function. Okay. So here it's like a process, how to process the JLM model. Okay, it's not something straightforward. Okay, you have different things you have to do it before running the model. First, data collection you have to check the data and what kind of data do you need. Okay, and after you collect the data, you have to do like a exploratory data analysis. It's like a summary of the data to check if the data is completed, or maybe you have some blank values in your data. These blank values, maybe you want to delete it, or maybe to replace it with the average, okay? Or you can come back to the company where the data is collected, okay? You can tell them that the data is wrong. Okay, so there is a different process, you can do it here. So after all this, you have a data cleaned. Once the data cleaned, now you can start with your JLM model. But before running the JLM model, you have to split your data between training and testing. Why we do this? Did you read about it? Okay, tell me. Yeah. Yeah. So the idea behind this, okay, it's not to have the best model that is 100% fitting the data. Okay, because why we do pricing? We do pricing first. We do pricing based on data for the past 3 years. Okay, and you want to sell a new product, or you want to sell same product but with the new rates or premium. Okay, so you have 1 year to sell this product. Okay, imagine you have this data. So we split the data between training and testing. We consider that the training data is the best data that I have, and the testing data is like the data that will be on the next 1 year. Okay, so as you said, yes, we split the data between 80% and 20%, or sometimes 70% or 30% testing. It depends on the size of the data. Okay, if you have a data enough, okay, we can say that 80% versus 20% testing data, so it's fine. Okay, and we run the model, yes, on the training data, and we run the output. What I mean is the output, the coefficient, okay, on the testing data, and we see and we compare the observed variables versus the predicted variables, and we see how are far or how much are they close to each other. Okay, and the idea, as I said, is not to have a model 100% fitting. It's not good. Okay, because you don't know what, because maybe the new product or the new business that you will sell, maybe it will not be similar to your previous business. Okay, so once you split it, okay, and you compare the results between observed and predicted variables. Okay, if of course we don't need to have, it's not good to have, for example, a difference 10% or 20%. Okay, of course the model is not significant here. So let's keep a margin about 2 or 3%. It will be enough. Okay, if you have a large difference, you have to redesign your model. For example, how we redesign the model? Maybe you selected a wrong variable. You have to see about this variable if it's important or not. Okay, so once maybe you decide that this variable is not important, I want to remove it from the model. Okay, you remove it from the model and you rerun your model and you compare the results again. If the output is improving, so it's fine, I can keep my model and I say, okay, it's my final model. Okay, and then the model is validated. Yeah. Clear, Young? Great, great. And here some graphs where we compare the observed observations, okay, versus the predicted one. You see the line in red, for example, here, the red is observed, the actual observation. And the line is in black. This line is the predicted one. So you see it's very close to each other. Okay, and similar in other graphs. You see that we have the same pattern like the observed observations. Okay, and very close. Okay, also we do like a confidence interval of my predicted variable. For example, here we take 5% lower and upper bound. Okay, and you can see that the predicted variables should not be over the 5% of my predicted one. Okay, this is how you control your model. Okay, or how to see that if your model is working well or not, or it's if it's significant or not. Okay, and here are and here is the output. The estimated here. What we say? Yeah, here are the estimated coefficient from the GLM model. You have these variables here, and for each one you have the coefficient. Okay, if you want, you can read more in the book. Okay, and next time I will find the other presentation is more clear than this one. Okay, maybe it's better, and if you want next week, like that, you will read more information about the GLM and you understand well about it. Okay, great, great. The equation. Okay. Yes, yes, yes. Yeah, right. You still see my screen? And you see the Excel? You see the Excel. Okay. Okay, here you have the graph. Okay, so for example, here we are looking at Central Asia. Okay, as before, we just put the R square. Okay, and we are trying to say how is correlated. Okay, by calculating the correlation coefficient. Okay, but looking at the graph, maybe it's not that clear. Yeah, one time you asked me this. So I'll show you how we calculate it. Okay, you have these options, format trend line. Okay, I think you know that. Yeah. The trend line option, you have the linear one line, you have the exponential,